All right, so now that we've talked about the special triangles, the 30, 60, 90 triangle, and the 45, 45, 90 triangle, and we talked about sine, cosine, and tangent, and those special triangles is related to the cosine, sine, and tangent. We're going to talk about how those are related on the coordinate planes in relationship to a triangle, and if those vertices were of the 90-degree angle were on the circumference of that triangle, and what that coordinate point would be if it laid on that circumference of that triangle. Right, so let's kind of illustrate for you what I'm talking about here. Okay, so say I had some radius of some circle. Right, I'm going to use my orange here. You'll understand why in a minute if you've been paying attention to the color code. Some radius of some circle, right? And the radius, of course, would be the hypotenuse of a triangle, right? If you made a right, I'm gonna make my y's here. My radius is 1, right? Of this, you see here that on my coordinate plane that I made each one of these blocks 0.5, right? So my radius here, if I were to take this all the way here, my radius equals 1. My radius equals 1. And it is also, if I were to make this make my y coordinates, my up and downs, if I were to drop a horizontal down and make this into a right triangle, right, and then I were to make my right triangle, I could say that this leg here would be my y coordinate, and then I'll make my green coordinate would be my x coordinate, right? You can see what I'm putting down here. My green coordinate here would be my x coordinates, right? And then if I had a triangle that would represent this point here on my coordinate plane, right? This coordinate pair, right? The distance of this coordinate from my coordinate point would be r, right? Would be my radius of this triangle, which is also the hypotenuse of this right triangle. And the coordinate points would be my x value, my distance of my x value from my origin. And it would also be my y value would be the distance in y. Okay? Now let's say, for instance, I wanted to identify this angle here, this theta. This angle, I wanted to name this theta. I wanted to name that angle theta. So what would, and if this radius here equals 1, right? Because if I were to take this and I were to bring it all the way up to here, you'd see that it would, if I made x 0, right, or if I made y 0, right, the length, the radius of this circle is 1 here, right? It intercepts, each one of these blocks here is 0.5, right? So the radius here is 1, okay? So the sine of this angle here would be the x value, the y value because its opposite is my y value over 1. It's also my opposite over my hypotenuse, right? My opposite over my hypotenuse. Or I can just say that it is my y value. So on a coordinate plane, okay, because the 1 is y, right? My sine on a coordinate circle in this quadrant, right? My sine is my y value, right? The cosine, right, is my x value. It's adjacent. It's adjacent over opposite, right? It's my x over 1, right? Because it's adjacent over opposite. Sine was opposite over hypotenuse. Cosine is adjacent over hypotenuse. So if my cosine is 1, or if my hypotenuse is 1, then my cosine is just that. It's just x. Okay? So if I'm just going to make my, if I'm going to substitute xy into my coordinate pair, right, with what I know, I'm going to take x is now going to be cosine of theta, and y is sine of theta, right? And if I'm going to expand the circle beyond 1, right, it's just I multiply 1, right? I multiply my sine of theta by whatever I have expanded my radius by. But what is tan of theta? Well, tan of theta is opposite over adjacent, right? So it's x, opposite is y, opposite is y over x. And if you substitute, well, we know y is sine of theta, and x is cosine of theta. Okay, so that's just some other way of defining tangent, cosine, sine, and the coordinate points for this point on the unit circle. Okay, in generic terms of theta, right? So I don't know what theta is right now. I don't know what x or y is, right? So just in generic terms, you can identify cosine and sine as the new points for this point on the circle, right? Your sine is y, it's your x and it's your up and down value, and your x is cosine. Okay, so let's move on to like an example for your 30 degree one here. Right, so I'm going to use like my little mini protractor here best I can and mark like a 30 degree mark. Right, so I'm going to rotate this guy like, let's see, that's 90 degrees. Actually, so the way I look at this thing, I gotta put that there, and I'm gonna put that there. Yeah, I gotta put that there because that's my 0 degrees. I'll show you guys how I'm doing this. Okay, yeah, so this is 0 degrees right here. That's 0 degrees. I gotta use my orange. That is 0 degrees right there. That is 90 degrees right there. Okay, so I'm going to mark my 30 degree mark is also my 150 degree mark, and I'm going to make a little mark right there. Okay, go from here to there, and then that will be through like my best point I can determine to be my vertex. Best I can through that to there. That'll be my hypotenuse for 30 degrees. Zoom back out. Okay. That's my, and that's r. R equals 1. Okay. Also my hypotenuse equals 1. Right? I'll also put hypotenuse. Okay, and then I have my x value. Let me do my y value first. Make sure it's a nice straight 90-degree mark here, best I can at least. So I'm going to do a 90-degree mark, but I'm going to extend this 90-degree mark with some dotted lines here, because I want to show you something else. Okay, so this is my 90-degree mark, and this y value without the dotted lines is my sine, right? Because I'm going to go off of theta right here. Theta, which I know is 30 degrees. Okay. All right, and then I have this right here. I have this right here is x. Is x. Okay, well, let me ask a hypothetical here. First, I'm gonna take this and I'm gonna draw another line. I'm gonna make an equilateral triangle. Okay. All right, I'm gonna make this dotted, I guess here. My dotted. I'm gonna erase that and make it dotted. That's to not confuse anybody. This is my dotted equilateral triangle that mirrors my other equilateral triangle. So, or my other triangle, right? So, if this was an equilateral triangle, okay, that means that this would equal 1, right? All of these, if this was 30 degrees, this would be 30 degrees, right? And then this would equal, this whole thing would equal 1, right? This would equal 1, and then this would equal 1, right? And then this green x would bisect this 60-degree angle right here, right? This 60-degree angle, because this is a 60-degree angle. That's a 60-degree angle, and this is a 60-degree angle, right? But this blue one would bisect that 60-degree angle to make two 30-degree angles. Okay. And then therefore it would make y. What would be the value of y? Well, y would be half of r, right? So let's label this thing. Let's label this triangle. Label this triangle A, B, C, and D. Right, so BC would be equal to 1. We'll color that one as 1. BC will be equal to 1 because this is an equilateral triangle, right? All the lengths are the same. All of these would be 60 degrees. Okay. CD and BC, or BD, right? CD and we'll say this BD is more applicable for what we're trying to teach. Right, BD right here is 1/2 of BC, right, which is 1/2, right? So that is what, kind of illustrates where we get the rule of the 30, 60, 90 triangles, that the short side of the triangle is 1/2 the hypotenuse, or two short sides is two short sides are equal to one hypotenuse. Okay, so we know that the sine of theta, right? The sine of 30 degrees equals what? The sine of 30 degrees equals 0.5, right? Because we already recognize that the length of this with opposite over adjacent, right? This is what this is, right? The opposite is 0.5 over 1. That's 1/2, right? We'll do that math a little bit better, right? So the sine of theta equals BD over AB, which equals 0.5 over 1, which equals 1/2, or 0.550 to be more specific. Because we always like to do at least hundredths for sine, cosine, tangent. All right, so how do we figure out what the cosine is? Okay, well, aside from knowing that little trick that we learned the other day, right, we can figure out cosine again by saying that x squared, remember cosine equals, if we figure out cosine equals, right, our lengths here, x, y, z, or x, y, this is our z, right? If we're going to do x, y, z, right, our cosine, our length, is going to be equal to, this should be orange anyway, is going to be equal to, in order to find that, we have to use Pythagorean's theorem, right? It's the z squared equals x squared plus y squared, right? To solve for y, or to solve for x, it's going to be z squared minus y squared. Okay, so we plug some numbers in, and we say that it's going to be 1 squared minus, let's put this here, z squared minus y squared, in case I need more lines for this. Okay, so this is going to be 1 squared minus, minus, let me zoom in for the algebra here, 1 squared minus 1 divided by 2 squared. Okay, when you have a fraction squared, it's going to be 1, you square both the top and the bottom, minus 1/4. Right, but you still have the square root on both sides squared. Okay, so how do you subtract 1 minus 1/4? Well, that's 4/4 minus 1/4, right? So 4/4 minus 1/4, or you can just go 1 minus 1/4 equals 3/4. So that's 3/4. 3/4. I have to square it, right, to get rid of the x. Okay, so that's going to be equal to, well, I guess the square root of 3 over square root of 4. Okay, so this is going to be equal to square root of 3 over 2. Okay, so the cosine of x equals, well, the cosine of theta equals x, which equals square root of 3 over 2. Okay, so that is how you figure out what the x value is for this angle. Okay, and notice that this is the long side, the long distance from an axis is square root of 3 over 2. All right, so our x value, this actually should all be green. Sorry about that. But our x value is square root of 3 over 2, right? And our y value is 0.5, or 1/2. Okay, so those are the 2 points for this point pair: square root of 3 over 2 and 1/2. All right, so let's look at something over here. I want you guys to kind of take note. For a 30, 60, 90 triangle, if I were to take this triangle and I were to flip it and push it up this way, I would still have, like if I were to write it here, if I were to put it here, it's kind of like this triangle, but flipped and put down. Right? I have a short side and a long side of a 30, 60, 90 triangle. Okay? You only have to remember for a 30, 60, 90 triangle these 2 coordinates. Like these 2 numbers. Okay? And this is out of the 3 points that you're going to need to know along this arc, right? Whether it's whatever quadrant it is, these are the 3 values you need to know. One of them is 1/2, and the other one is 3 square root of 2. Right? One of those is the short standard value from an axis. The other one is the long standard value from the axis. Right? Because whether you are looking at the relative value from the y-axis, right, for the x value here, right, from here to here, this is the 60-degree angle. From here to here, right, for this triangle, this, where'd my orange one go? For this triangle, which is the 90-degree angle. Oh, sorry, this is the 60-degree triangle, right? And this was the 90-degree. Give me a second to draw all these up again. My green is my x-axis. My distance from the y-axis, which is my x value. And the y is my distance from, the green is my distance from my y-axis, which is my x value. And the burgundy is the distance from my x-axis, which is my y value. Maybe it'll be clearer if I do this. Yeah, it'll be clearer if I do this. And I do this. Here, I'll be more clear, I think. Okay. I'm purely talking about these points here, this point here, and this point here. Okay, so I have a reference axis. For my reference axis, let's explain this table here. For the reference axis, I'm figuring out this is so these tables that I'm filling out here will help you label what point it is along this reference circle. Okay, because the purpose of this exercise is to figure out what the point coordinate pair is anywhere along the unit circle. Okay, so the first table is the reference axis that you're talking about. Okay, so this is either the green or the burgundy lines. Okay, so the green or the burgundy lines, the reference axis for the green line is distance. We're referencing next thing we're going to do is talk about short, medium, or long distance. Okay, so the distance that we're referencing is the distance from the y-axis. That is when we're figuring out the distance from the y-axis, we are reading the x. We're talking about the x value. Okay, because the distance from the y-axis is the x value. Okay, and then the distance from the x-axis is the y value. How far we are away from the x-axis is the y value. Okay, it can be confusing if you don't think about it. Okay, how high it is, which is the distance from the x-axis, is the y value. How far over it is, one way or the other, is the x value. Right, so just don't confuse that. It seems pretty complicated. If you can mess it up, so don't get that'll result in your points being flip-flopped if you screw it up. Okay. All right, so now we're going to talk about the relative distance from the axis. Right, so you know if it's x or y. And now we're going to talk about what the standard value is going to be. We've already identified two of them. Right, 1/2 and 3 square root of 2. Okay, so if you look at this green line here, just focus on the green line. Right, the distance from the y-axis for the x value for here, this one was 3 square root of 2. Right, so our longest value, right, if you look at these three values here between this one, and this one, the longest value you're going to get, right, is 3, is going to be 3, the square root of 3 divided by 2, right? That's going to be less than 1, right? Has to be, right? Because the longest length on this thing is 1. The longest length on this is 1. Let me go down a little bit so you guys can see that. The longest length is 1, so all of these are going to be less than 1. Right, but the longest one of all these is 3 square root of 2. Now if it doesn't matter, if you look at the burgundy one, right, the burgundy one is also 3 square root of 2, because it's just this it's just this 30-degree triangle flipped up this way, right? It just flipped axes. Okay, your short value that we talked about already is, we talked about it down here, right? It's 1/2. It's 1/2. It's from your 30, 60, 90-degree triangle. Now, depending upon if it's oriented this way or it's oriented this way, right? That's your short value. Okay? Your medium value has to do with your 45-degree triangle. Okay? So what is your 45-degree triangle value? Well, let's figure that out now. Okay? Your 45-degree triangle, let's see, your hypotenuse is here for your 45-degree triangle. Okay, your hypotenuse is there. And then you have your x and your y, and you know what? They're going to be the same both times, right? Because your x and your y value for your hypotenuse or for your x, they're going to be the same. Okay? So for that one, if you have the square, if you have a hypotenuse, which is 1, right? And you do the sine, or you do the hypotenuse, the cosine or sine of 45, which is, let's do this on like, we'll do this right here, I guess. We'll do the sine of 45. Sine of 45 equals opposite over hypotenuse. We know the hypotenuse is 1, and we're trying to figure out x. Okay, zoom in a little bit. Okay, so we're trying to solve for x. So now that we just say that what is solve for x? Now it's just the sine of 45. Okay, so the sine of 45, you'll notice that here that the 45 sine equals that. But for sine of 45, cosine of 45, it's the same thing. Well, what is that value, if you can remember, in regular terms? Well, if you can remember, square root of 2 divided by 2, that's that value there. We went over that in last episode, or yeah, last series, right? So that value, I'm gonna make that value, I guess orange. I haven't used that one yet. That value is square root of 2 over 2, and it'll be that one for both. Well, you can't see that. Sorry, it's a square root of 2 over 2. So it'll be that value for both the x and y value. Okay? So then we have to figure out what quadrant these are in, right? If it is in the quadrant 1, both x's and the y's, I'm gonna make this blue, x's and the y's are positive. Okay? If it is in quadrant 2, the x's are negative and the y's are positive. Right? Everything is above the x-axis, so all the y's are positive. In quadrant 3, everything is negative. And in quadrant 4, all the x's are positive and the y's are negative. Okay, so let's look at a point for an example. So we'll say an example. The point we'll say is like right. We'll say it's this point right here. Okay. Actually, it needs to be over more. Let's say it's this point right here. Okay. So what, using the table, what point is it? Or what reference axis is it? It's in 4, right? So the x-axis will be positive and the y will be negative. Okay, what's the relative distance? Well, for the x value, the relative distance is from the relative distance from the x-axis. For x, it's I'm looking at the remember my reference point, my reference axis for my point pair. I'm looking at the y, right? So my relative distance is short, right? It's the short one. For my y, it's got to be the long one. Okay, because this is the medium, right? And then this would be, well, this is the medium. This is the medium, and this is the short, and I'm doing this one. Okay, so my standard value for short is 1/2, and my standard value for long is square root of 3 over 2. Okay, so, oh, sorry, this is the reference axis. Sorry about that. So my reference axis was y, and my my reference axis for this one was been x. So reference axis was y, it was the short one, and then my reference axis was for this one was y, was x, and so was my long one. The quadrant was 4. Quadrant was 4, so my sign is negative for x, or positive for x, and negative for y. So what is my point pair? My point pair is 1/2 and negative square root of 3 over 2. Okay, so that is how you use that table. It's good to memorize that table, or at least that process, and then these 3 numbers, right? That way you don't have to memorize all the way around, right? These 3 numbers are pretty good to know. 1/2 for short, square root of 2 for 2, over for medium, and square root of 3 for over 2 for long, right? So it's 0.5, 0.707, and then like 8.7 something. Okay, so hopefully that works out for you guys, and you understand the unit circle. Exercise for this one is just a bunch of very random points. Try this thing. Start with your reference axis. Okay, well, I'm going to go from this one to my y-axis, so that's going to be my x value. This one to my x-axis, and that's going to be my y value. Is it my short, medium, or long distance? Right, and you're only going to be asked these 3 ones, right? And if it's on your 90s or your zeros, right, your 90, right, is just your sign, right? So it's 1. Your is 1, 0, right? If it's on your x, it's just your cosine. So it's 0, 1 for y, and then it's just your cosine, so it's 1, 0. Okay. So I hope that works out for you guys, and I hope you understand all that stuff. These are the numbers to remember: 1/2, square root of 2 over 2, square root of 3 over 2. So easiest way to remember it is this way. Memorizing it all the way around, you'll lose your mind. Okay. On to 7.8 after this.